this video, we want to integrate x over the square root of x squared plus x plus 3. So let's rewrite x as 1/2 times the quantity 2x plus 1 minus a half, because now I can break this up into two separate fractions, and then the 1/2 will just come down in the denominator, so we'll just multiply the denominator by 2, and then we could just factor out the 1/2. So now we could just focus on the first fraction. So in order to solve this, we have to do u substitution. Let u equal x squared plus x plus 3. du is 2x plus 1 dx. So that's just 1/2 integral du over u to the 1/2 power, which is just u to the 1/2 plus c. And then u we said was x squared plus x plus 3. So we end up with the square root of x squared plus x plus 3 plus a constant c. And that leaves us with solving this integral, and then we'll be done. So for this one, we want to complete the square. And the way we want to complete the square is by breaking up 3 in terms of 1/4 and 11 over 4. And the idea is you take the middle term here, coefficient is 1, divide it by 2, and square it is 1/4. Okay, so that's how I got the 1/4 here. And now I'm going to combine x squared plus x plus 1/4 as just x plus 1/2 quantity squared. From here, we're going to do a u substitution. So the goal here is, can we get this in terms of u squared plus 1 in the denominator inside the square root? Well, we can do that by letting u equal 2x plus 1 over the square root of 11, which means du is 2 over square root of 11 dx. And so we'll replace dx with square root of 11 over 2 du. In the denominator, we have the square root of 11u squared over 4 plus 11 over 4. And now we can factor out 11 over 4 in the denominator, bring it outside. The square root of 4 becomes 1/2 here, and it cancels with the 2 outside. And then we have a square root of 11, which will cancel on the top. And then we'll get the 1/2 integral 1 over the square root of u squared plus 1 du, which this is a common integral, and that's 1/2 ln of the absolute value of u squared plus 1 plus u. Technically plus c, but we already have the plus c from the previous problem, so that's okay. And then we said u was a 2x plus 1 over root 11. Plug that in there, and then distribute the square. 2x plus 1 squared is 4x squared plus 4x plus 1. The square root of 11 squared is 11. And we're going to add these two terms. You can think of 1 as just 11 over 11, and then 11 is going to add 1 in the top to become 12. From here, we can factor out this 11 on the bottom. So it's going to come outside as 1 over square root of 11. And notice that both of these terms have the square root of 11 in the denominator, so we can factor that out. And then we can factor out a 4 from 4x squared plus 4x plus 12. And this 4 is going to come outside the square root as 2. And then, let's see, from here, I factor out another 2. So the 2, there's a 2 in here and the 2 here, so we factor out a 2 from these terms, and you have the 1 out here. And now we can use a log property where if you have ln of a times b, that's the same thing as ln of a plus ln of b. So you see like the 1 over square root of 11 is multiplying this whole thing. The 1/2 ln of 1 over square root of 11 is just a constant, so we'll just say that's c. And then we have the 1/2 ln of this. So we said that there were two integrals. The first integral was square root of x squared plus x plus 3 plus c. The second integral we just solved for. Combine these together and get this as my answer, which if you want, you can simplify the second term as 1/2 inverse sine of 2x plus 1 over square root 11. And so that is our final answer.